Hello guys, in this video we are going to discuss the solution of the problem word break. So let us look at the problem statement. The problem statement says that we are given a string S and a dictionary of n words dictionary. Find out if S can be segmented into a space separated sequence of dictionary words. Return 1 if it is possible to break the S into sequence of dictionary words, else return 0. So let us try to understand the problem statement with the help of an example. So in the example, the length of the dictionary which is given to us is 6, and the dictionary which is given to us contains words. So this dictionary is a list and it contains words which are I and mobile. So these are the words which are present in the dictionary, and we are asked that given a string S, so the string which is given to us is S. So given this string, is it possible to use dictionary in order to generate this word? Okay. So for instance, if I used the words which are there in the dictionary, so let me just write dictionary as dict. So at 0th index, the word which is given to us is I, and at first index, the word which is given to us is like, right? And if we combine these two words, so if I combine dict 0 and dict 1, then I would be able to get the string S. So given an S and a dictionary, is it possible to form the string S using the words of the dictionary? If that is the case, then I'm going to return 1. Okay. So in this particular case, since we are able to form it like this, so I'm going to return 1. Otherwise, let us say if we are not able to form it, then we need to return 0 in this particular case. So that's about the problem statement, folks. Now let us see how we will be able to solve this problem. So the solution which I'm going to give, so there are multiple solutions to this problem, but the solution I think it was more intuitive and it was easy to implement as well as easy to understand, and that is the solution I'm going to discuss here. And the solution is based on trie data structure. Okay. So let us first understand what a trie data structure simply means. So a trie data structure is a data structure which contains nodes, and each node has 26 children. So this is the node, and this node has in total 26 children. Okay. The node will not contain any value over here. So the in itself the node does not contain any value, and these 26 children, so like 26 children which we have, so these 26 children simply means are the letters from A to Z. Okay. So let us say if the character A is present, then this transition will be represented by A, and in this particular case this node will be valid. Okay, valid in the sense this will be a non-none node. Okay, let me just write it out. Not none node. We will walk over an example in order to understand it more clearly, and hopefully that will explain it. But for now, let us assume that trie is a data structure where a node contains 26 children, and it also contains one more information, whether the given node is a leaf node. Okay, node is a leaf node. So if I have to write it in the form of a class, so in Python we can represent it as like class, and let's say like trie. And once we have trie, then so let's have the constructor for this class in it self, and what all it contains is it contains children. So self dot children, and the number of children is 26. So initially, and the default value of all the children will be none, and this we want it to be 26. So let me just declare it. So the numbers of children is 26, and it also contains a value which is this a leaf node? Leaf node, and the default value we are going to set it as false, that this is not a leaf node. Okay, so that's the code interpretation of it. And so in a sense, what we want to understand here is trie is a data structure which contains a node, and each of these nodes will have 26 children. The default value, we will say that there isn't exist any children as such for the for a given node, and apart from this we will have something known as leaf node, which if it is a leaf node then we are going to set it to true, otherwise it remains false. So let us walk through an example in order to understand it. So let us say so let's take the dictionary which we have. Okay, so the dictionary which is given to us contains words such as I. So let us see how we will be able to store this information in a trie data structure. So to begin with, we will have an empty node with us, or a node with us, and it will have 26 children. As of now, all its children are null. The first word which we want to store is I. So let us store it. So what will happen is it contains just one node. Okay, this is another node, and this transition is I. Okay, so remember this node has 26 children. Okay, let us say A corresponds to 0, 0th children, B corresponds to 1th children, C corresponds to 2nd, and so on. Z corresponds to 25th children. So this is I simply means whatever will be the number. So let me just write it down. D is 3, E is 4, F is 5, G is 6, H is 7, and I is 8. So the 8th children is what we are going to set a value for an 8th children, and since we know that it is the 8th children whose value I have set it to true, because of which we know that this transition is I. Okay, so this is I, and now since this is the leaf node also, so leaf node simply means the end, right? So I contains only just one letter in it, which is I itself, because of which this is also our leaf node. And let me represent the leaf node with a green color. So this is my leaf node, and in code we are going to set the leaf node for this particular node as true. Okay, now let's represent like in this similarly in this form. So this transition will be what will be this? This is my L. Then comes I. So again, this node will have 26 children. Initially, all the values will be none. Then I am going to set the value for I. So this is my I. Then again, the same thing. Then this will have K. Same thing. And then we will have E. Okay. So E. And this, since this is a leaf node, E is a leaf node. So I'm going to set it to green color, which simply means leaf node is set to true. Now let's represent Sam over here. So Sam will be something like S. So this will be my S, then A, and then M. Okay, and this is going to be like this. Okay, similarly Sam, then this letter sung, S-U-N-G. So S is already there, which is fine. Then I'm going to have U over here, and then I'm going to have N, and then G. Sorry about this, and a G. And since G is my leaf node, so I'm going to make it as green. Okay, and then let us represent Samsung in itself. So Samsung, let us see Samsung. So S A M is already there. It is just that we have to represent SUNG. So from here it will be S. Sorry about that. This is my S. Then U. Then N. And let me just I turn over here, and this is my G. And since this is the last character of the word, so I'm going to mark it as leaf node. And then now the mobile, let us represent mobile also. So M is not here. So let's have an M over here. So let me just draw it from here. Let's call it M. Sorry about that. So this is my M. Then O, B, I, L, and E. Okay. So this is how we will be able to represent the dictionary in the form of trie data structure. So in order to solve this problem, what we are going to do is we are going to first represent the dictionary in a trie data structure. So what we are going to do is, the first thing which we are going to do is represent dictionary in a trie data structure. Okay, and once we have that, then we are going to search the string s, which we want to search in trie DS data structure. Okay, so let us say this the trie data structure. So let us say we were able to form this trie data structure on a particular dictionary. Now let us see how we will be able to search it. Okay, so the way this search will work is, what we are going to do is, to search a string, we are going to say that for I in range 1 to, let us say the length of string s is len of s plus 1. Okay, and so what we are going to say is we will search s from beginning till I. Okay, we are going to search this particular string in our trie data structure. If this is true, if we are able to find this, then we are going to search the remaining string in trie data structure. Okay, so let us walk over an example in order to understand this. So let us say this is the trie data structure which we have, and let us say that we want to search the string I like. Okay, let us say we want to search this. So the first thing which we are going to do is we are going to have a partition over here. So like first position, so S0, and then so we are going to break this into this part, S1 to n, where n is the length of the string. And now what we are going to do is that first we are going to search this in our trie data structure. So we can see that the word I exists in the trie data structure. Okay, this transition I, and this is also a leaf node, right? So it should end, the word should end with a leaf node also, and that is how the search will be completed. So since I exists in the trie data structure, now what we are going to do is we are going to search for like. Okay, so I we have already searched for. Now we are going to search for like in the trie data structure. So as it turns out, like is also there, L, I, K, and E, and then E is also a leaf node. So since I was able to search I, and I was able to search like in the trie data structure, so that is how we are going to return 1 for this particular case. Okay, let's take one more example to understand the concept a little bit better. Let's say this time I want to search I like Samsung. Okay, So this is what I want to search. So again, what we are going to do is we are going to partition it. So we are going to partition it in this way. So S0, and then, so first I'm going to search S0, and once I have searched S0, and if S0 has been found, then I'm going to search for S1 to N, and N is the length of the string. So let us first search S0. S0 again is I. So S0 is found. Now I'm going to search like Samsung. Like Samsung. So this is what we want to search. Again, what we are going to do is we are going to partition this as like this. Okay. So we have partitioned it, and we will try to find L in our trie data structure. So L is there, but this L is not, this node is not a leaf node, because of which we will conclude that L alone is not there in the trie data structure. Okay, so the first partitioning would be something like S1, right? This is the first character, like remember that this is 0 and L is at first index. So S1, and the other one is 2 to N. Okay, and this we concluded that S1 is something which we can't find it, so we will not worry about this portion. Now we will move to the next portion, wherein we would like to search. We want to conduct our search in this particular way. So let me write it as 1 2 3, right? Because this is essentially S1 and S2, right? And then this will be equals to S3 to N. So now let us look for 1 and 2. So 1 and 2 is what? Li. Again Li, right? Now this time I want to search for Li. Li is again there in our trie data structure, but this particular node is not a leaf node. So that is how we will conclude that this again is not there in our trie data structure. Now this, and next, now we will increase our partitioning. So now this partitioning will be 1 4 plus S 4 to N. Again, this is like, these three characters we want to search it. These three characters are there in the data structure, trie data structure, but the last character is not a leaf node, so we are going to conclude that this is also not there in our trie data structure. Now the other partitioning will be 1 to 5 and from 5th to N. Okay, so 1 to 5 is what? Like, Like. So here we see, if we go through Like, then we will be able to get to this node. This is a leaf node, so we conclude that this is something which is there in our data structure. And then we would like to search the remaining string, or the remaining portion of the string. So the remaining portion of the string is what? Well, the remaining portion of the string is Samsung. Samsung. Now again, so remember, this is at 5th index, as this index is 5th index. So what we are going to do is, again, we are going to partition it as S5. So now we want to search for Samsung. Remember, so far we have searched for I, which we have found it, and the next letter which we have searched for is like, and this is something which we have found it. Now we want to search for Samsung. Okay, so again the partitioning will be happen at, so this is my 5th index, 5th to 5th, 5th to 6th, sorry, and then S6 to the remaining. So the 5th character is S. Remember our trie data structure. So S is there, but then this is not the leaf node, so we will conclude that this is not there in our data structure. Okay, and we will move forward in our partitioning. This time it will be from 5 to 7, and this will be from 7 to N. Well, 5 to 7 is what? S and A. S and A is again there in our data structure, but it is not a leaf node, so this again will not be, we will conclude that this is not there in our dictionary. Now we'll move forward. This will be 5 to 8, and this will be from S remaining, so 8 to N. This 5 to 8 is what? SAM. This is SAM. So again, SAM is there in our data structure, but Oh yeah, Sam is there in our data structure. I'm sorry about that. So see here, S, A, and M is also a leaf node. So this is there in our data structure, and then we are going to conclude that this is something which we have found it. Now we are looking from. Now all we need to see is whether we are able to found the remaining or find the remaining elements or the remaining string. So now the remaining string is SUNNG. This is what we want to find out, and this is my 8th character. Again, the partitioning will be 8 to 9 plus S 9 to N. This is something which is not there in our data structure. I mean, S is there, but then S is not a leaf node, so we are going to cross this. Again, we are going to increase our counters. So this will be 8 to 10, and this will be 10 to N. This again is not there in our data structure, so we are going to cross this. And then we are going to look for the other one, which is 8 to 11, and then the remaining 11 to N. 8 to 11 is SUNN, right? Yes, SUNN, and SUN is there in our dictionary, but that is not, N is not the leaf node, so we are going to cross this. And now let's see this, and then we are going to look for 8 to 12, and this will be 12 to N. Okay, so here this is SUNNG. SUNG is there in our trie data structure, and G is our last node. So this is what I'm talking about, SUNNG, and G is my leaf node. So in that way, we will be able to conclude that SUNG is there in our data structure, and this is my last node. So sorry, this is like an empty string now, right? It does not contain any element. So this, for like the empty string, we are going to say that this is found in the data structure. So in this way, we will be able to search the string in our data structure, and we are going to return 1 in this particular case. Okay, so that's about the explanation, folks. And what I'm going to do is that I'm not going to invest a lot of time on the trie data structure. I will be covering it, but not in depth. I have made another video on trie data structure. I'll be linking that in the description. Take a look on that one. That will help you in making the concept of trie data structure more clear. For now, let's proceed forward and move to our coding section. So this is how we have coded it. So this is the trie data structure which we have talked about. And so in the trie data structure, we are basically worried about two things, which is insert. Okay, so this is my insert module, and this is my search module. So these are the two functions which we are worried about. And this is the init function, which is like there are 26 children for it, and each of the children is none. And for now, by default, we will assume that this is not a leaf node. Okay, now let us see how we are able to insert a node in a trie data structure, or a word in a trie data structure. So this is the word which we want to insert in the trie data structure, which is pointed by root. Okay, so we'll have a pointer ptr which will points to root. We will check that whether the character, right? So this is like elements in character in word. So the first character or the character, whether there exists a transition for that or not. For a particular character, whether there exists a transition. If it does not, there isn't exist a transition, we are going to create a node for it, and we are going to store that value at that particular, and we are going to update it. And once we have inserted all the words, okay, once we have inserted all the words, so here by this we will be able to insert all the words in the, or sorry, all the characters of a word in the trie data structure. Then the last node, we are going to set it as leaf node, and we are going to set it as true. And towards the end, we are going to return root. Okay, I'm not going in depth of these things, because otherwise the video will become very long. And let's just quickly glance over the search. So search is this thing. we want to look for this string in the trie data structure. So this is how we will be looking at it. If let us say for a particular character there isn't exist any transition, then we can conclude that that particular word does not exist in the trie data structure, and because of which we will be returning false. Otherwise we will adjust our pointer appropriately and we will move forward. Okay, and after searching it, trie data structure, we have found all the characters, then the last character has to be a leaf node also. So this is that check that the last character is a leaf node. If the last character is a leaf node also, then we are going to return true, saying that the string or the word was found in the trie data structure. Otherwise we are going to return false. Okay, so that's about the trie data structure. And once we have that, then the search is something which we are doing it something like this. So the search is something which we are doing it like this. So first we are creating a node for root, which is a trie data structure, and then we are inserting the dictionary in a trie data structure. Once we have inserted it, then we are searching for that particular string in the trie data structure. And how does the search algorithm looks like? Well, the search is something I in range 1 to a length of s plus 1. So the first thing which we are going to do is that we are going to check the from 0th index to ith index characters in the trie data structure. If that is true, then we are going to search the remaining. So this is something recursion which we have done over here. And if towards the end of it we are able to search all these things, then we are going to return 1. Otherwise we are going to return 0. So that's about the code, folks. Now let us submit our solution. So our solution got accepted. So that is from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I will try to address them. Thank you.